And again, from the National Weather Service in Raleigh, this is the SKYWARN Severe Weather Reporting and Safety class. Again, good evening to everyone. Nick Petro, Warning Coordination Meteorologist here at National Weather Service Raleigh. And let's go ahead and get right into our training slides. So first, just a quick little introduction about National Weather Service Raleigh. We're located physically on NC State Centennial Campus. And reason being is because NC State has a really good meteorology program. One of the few universities in the state that offers meteorology as a major, undergrad major. So we have our office space there on Centennial Campus, which is just a very short walk or drive to the meteorology department, and gives us an opportunity to do collaborative work with the university. There's a look inside of our operations center, and you can see a lot of folks working at that point in time. Typically on a day shift or evening shift or overnight shift with quiet weather, typically there's 2 or 3 people there. But this photo was taken on a day when we were experiencing severe weather, and it was more of an all hands on deck situation. We've got 8 workstations set up in our operations center. There is our there's our county warning area for Central North Carolina. 31 counties in Central North Carolina is the part of North Carolina that we serve. Now, just kind of from the 50,000-foot view, big picture, this is what the National Weather Service does. We provide weather forecasts, 7-day forecasts, so that you can be prepared. We provide hazardous weather warnings for the protection of life and property. We're the official government agency with the responsibility of issuing this country's weather warnings for the protection of life and property. And then finally, we provide weather data that anyone can use, satellite, radar, model data, surface observation data, that many of our core partners use. In fact, our media partners use as well. And as I kind of already alluded to, we serve in Raleigh, Central North Carolina. Our office is one of 122 offices around the country. Each dot on the map represents a city where we have a National Weather Service office, and we, again, serve all of Central North Carolina. This is our #1 mission: issue warnings for hazardous weather for the protection and life and property. So no matter where you get that warning, how you receive it, no matter how it comes to you, whether it's you're watching TV or whether it shows up on your cell phone, it originates from the National Weather Service in Raleigh for Central North Carolina. All right, so shifting gears, let's talk about SKYWARN, what the program is all about, why we have it. It goes all the way back to the 1960s. Trained weather spotters who gave us reports. And who can be a spotter? It could be anyone with an interest in weather. As I alluded to, spotters could be anybody: concerned citizens, amateur radio operators, truck drivers, you name it. If you have an interest in weather, you could be a good spotter. So anyway, what we do not do is we do not teach this SKYWARN class for you to become a chaser. Okay, if you go out and chase storms, it's not on behalf of SKYWARN. That's on behalf of yourself. Safety is our top priority. So that's why we do not teach storm chasing. Okay, the main thing is you want to, #1, take care of yourself. Make sure you're safe. Make sure your family's safe, your coworker, wherever you're at when severe weather strikes. Put safety as the top priority. And then if you happen to observe severe weather or experience damage, then give us a call and let us know. Okay? All right. Why do we even have spotters? What's the point in doing this class and having spotters? Because it's real simple. There's a lot of text on this screen, and the red letters there are basically the high points. Technology can't detect every instance of hazardous weather. There's we basically need that ground truth, confirming hazardous weather, provide verification so we can improve future warning services. SKYWARN spotters serve their local communities. But let me just kind of put it to you this way. One of our main tools for detecting severe weather is our radar. Okay, so the radar sees weather that happens above the ground in the sky, and we're scanning those storms. Our meteorologists at the National Weather Service are interpreting that data. They're making inferences on what's going on, and basically they're telling us, the radar tells us what we think's going to happen. Okay, so whereas the radar doesn't tell us what's happening at the ground. The radar doesn't tell us what's happening at the ground. People tell us what's happening at the ground. So, occasionally, obviously, severe weather may go over an automated weather station, maybe at an airport or someone's home that maybe has a weather station. But usually that's pretty. When severe weather goes over a automated station at the airport, that's pretty infrequent, pretty rare, and it doesn't happen very often. So really, we get our ground truth from people. So if I could summarize it in one sentence, the radar tells us what's happening in the sky. People tells us what's happening at the ground. And that's why we have a spotter program. When it comes to severe weather safety, okay? All right, so first step in severe weather safety, right? Because 2 slides ago, what did we say? We said safety is our top priority, right there at the bottom. That's why we don't do storm chasing. Again, if you want to chase, that's up to you, but again, it's not on behalf of SKYWARN, at least here in Central North Carolina. So since safety is our first step, then how do you stay safe when it comes to severe weather? Well, it's being informed. You need to be able to have a good tap into information. Nobody wants to be surprised, right? Nobody wants to be surprised that severe weather snuck up on them. So that doesn't happen very often these days. We usually, we're pretty good to the point where it's almost, surprises or unexpected severe weather is usually pretty infrequent. So my recommendation to everyone for first step in severe weather safety is just check the weather every day. Check our forecast at weather.gov/Raleigh. Turn on the TV, local, whoever your local favorite TV person is, go ahead and turn it on. Check it out in the morning. Listen to the NOAA radio, maybe, while you're getting ready for work or going out or just, over your cup of coffee in the morning. Check out weather.gov/Raleigh. Check out our hazardous weather outlook and see if there's a risk of severe weather. Again, those are some ways to know if severe weather is possible later today. In terms of getting the alert, that's step number 2 in safety. You want to make sure you have ways to get the alert. You may have checked the weather forecast in the morning. You might be aware that there's severe weather possible, but if you go out and leave for the day and then you don't have any way to get those weather warnings, well then you're still not prepared as you could be. So again, having a weather radio, no weather radio, subscribing to your county's reverse 911 system, making sure your wireless emergency alerts are turned on, downloading a free app that delivers weather warnings like the FEMA app or the Red Cross app, or really just as simple as turning on the TV local news channel when you see threatening weather approaching. So anyway, you want to make sure you have ways, multiple ways, redundant ways to get the alerts if severe weather is expected. Knowing where to go when there's a tornado. So the bottom layer of that house, theoretically is underground. It's a basement, right? So quickly move to your basement when a tornado warning is issued. Okay, but my house doesn't have a basement. My house was built on a concrete slab, so I don't have a basement. Okay, and if you're like me and you don't have a basement, you want to move to an interior room on the lowest floor with no windows. Okay, exterior rooms and rooms with windows do not protect you, and obviously top rooms do not protect you either. And no place outside is safe from a tornado. So again, you want to get down low or get into an interior room on the lowest floor. Mobile homes, for folks living in mobile homes, make plans ahead of time to stay with friends or family who live in a sturdy building, so that when a tornado watch, for example, is issued, maybe that's the time to call your friend who lives in a sturdy building and say, hey, if a warning's issued, can I come over and shelter with you? Okay, so that's the best thing to do for folks who live in mobile homes. The other thing I really want to remind folks is that flash flooding is really one of the biggest contributors to injuries and fatalities when it comes to weather safety or weather hazards in Central North Carolina. And of course, urban flooding is the most common type of flash flooding in Central North Carolina. And how does flooding happen? It's real simple. You know, the Earth has natural, when it rains, right? What happens to rain when rain runs off, right? It's some of it's absorbed into the ground, some of it runs off into streams, which the streams carry it to rivers, and rivers carry it to ocean. Remember the water cycle? We learned about that in grade school. And you know, clearly when it rains, that water's got to go somewhere, right? Well, there's natural water system, natural drainage systems, like I just mentioned. Well, there's also human-made drainage systems, like, you know, culverts and stormwater runoff drains, you know, ditches that are built into the side of the road, you know, to carry rainwater away, especially where there's a lot of concrete. Well, it's real simple. Those drainage passageways can only carry so much water at a given time. So when it rains so hard in a short period of time that it overwhelms either the natural or human-made drainage system, well, that water has nowhere to go but to back up and result in flooding. So that's what happens there typically in central North Carolina. And basic common sense can go a long way there. So if you encounter flooded roads or flooded areas, just don't drive through them. And sometimes it may look like you can get across a flooded roadway, but it's better to simply take a few extra minutes to turn around and find another way. So that's flash flood safety. Again, get to higher ground, don't drive into water, and stay informed. All right, when it comes to lightning, I can summarize lightning in one simple sentence. There is no place outside that's safe during lightning. Okay, no place. Dugouts, sheds, pavilions, picnic shelters, small structures, they don't provide shelter, adequate shelter, okay? They might keep you dry from the rain, but they don't provide adequate lightning shelter. You know what also people do to stay dry when they're outside during thunderstorms? They go under trees to stay dry, you know, and that is the absolute worst thing you can do. Never, ever get under a tree, okay? Because lightning likes to strike trees, and if you're standing next to the tree that gets struck, then that electricity can impact you as well, and you could be struck by lightning. Okay, you know, leave areas where there's water, like swimming pools. Don't stand near metal objects. Get away from water. Get away from metal. Okay, what you do want to do is get inside a sturdy house. Okay, a sturdy building, an enclosed building, or as a last resort, get in your car. Okay. All right, and then finally, when the storm is over, the rain ends, and things are kind of winding down, just give at least 30 minutes before you resume outdoor activities. Why? Because lightning can reach back to the places the storm had been previously. So as a storm is exiting, yeah, that storm might be leaving your area, but the lightning could still reach back, okay? So wait at least 30 minutes before you resume outdoor activities. All right, looking, you know, we talked about where to shelter for tornadoes. Remember this slide right here? That slide right there? Remember that slide because that applies for non-tornadic winds as well. And we call those straight line severe thunderstorm winds, okay? Because they can be just as powerful as a tornado. So the same safety rules apply as if it was a tornado when it comes to straight line damaging winds. All right, and since we're talking about damaging thunderstorm winds, I thought I'd include a slide that shows one of the most common sources of damaging straight line winds, and that's from downbursts. You know, when there's a big, tall, you know, huge thunderstorm that has a lot of rain and a lot of rain above, you know, above the ground, and it's just that all that water has weight to it. You know, I mean, it's pretty heavy. Eventually, the updraft that creates the storm can't hold it anymore, so that water just collapses down, and as we call the downburst. And once the water hits the ground and impacts the ground, that water has nowhere to go but to spread out. And when it spreads out, the dissipation phase, the downburst, at the leading edge of that downburst, the leading edge of that water and air that's moving away can be very, very windy, can have damaging winds at the leading edge of it. So, so that's the most common cause of damaging straight line winds. All right, when it comes to, there's a few other types that we're going to cover in terms of safety. Hail being the next one. You know, the real big baseball size hail, we only see that maybe 2 or 3 times a year. Most of the time, the most common hail size that we see here in central North Carolina is the size of a quarter or smaller. Okay, but nevertheless, you always want to get inside when we expect hail from the thunderstorm. Use common sense. Don't try to run through it. Seek shelter for your vehicle. If you have a garage, you know, and the severe thunderstorm warnings issued, you might want to just pull your car into the garage if you have room to do so. Okay, and remember, you know, although, you know, we're going to talk about this later, although we want you to report hail size, don't think you have to go out into the storm and measure it as it's happening. You could wait till the storm is over. That hail isn't going to melt super fast. It'll take a while before it melts. And even on hot days when, you know, temperatures are in the 80s and 90s, it'll take time before that hail melts. So just wait till the storm's over before you try to go outside and take any measurements. Again, when it comes to reporting hail, and again, I should have, you know, this is something that bears repeating. And I think most people will look at that image at the bottom and say, you know what? Actually, marbles do come in all kinds of sizes. So, we want to avoid using the term marble size hail, okay? And instead use objects of known size, like coins, okay? Or, you know, baseball. Hopefully you don't have to ever report baseball hail, but that's an object of known size that doesn't change. Or golf balls, you know, there's only one size of golf ball. So, you know, there's only one size of a quarter or one size of a penny. You know, pennies don't change size, right? So use something of a known size. Better yet, if you happen to have a ruler handy, go ahead and measure it. And again, wait till the hail is done, the storm is over, and wait until the lightning threat is over too. But what does a severe thunderstorm warning mean? It means take action. Get inside. And when we issue when we issue a severe thunderstorm warning, you don't necessarily have to go to the basement, but at least get inside and get away from windows. So that's my recommendation when it comes to severe thunderstorm warnings. All right, thunderstorm basics. We're gonna go into a little bit of the nuts and bolts of storms and severe weather. And I guess I could say the takeaway from this slide is what separates or what differentiates a severe thunderstorm from a non-severe thunderstorm. And really the answer to that question is at the bottom. Large hail, okay, inch in diameter or larger, you know, the size of hail that can cause damage, or sustained or winds or gusts of 58 miles per hour or stronger. And again, wind damage, you know, winds around 60 miles per hour and hail that's, you know, an inch or greater, that's when damage happens. So the severe thunderstorm is built around damage, okay? So we really want to make, you know, not all thunderstorms have damage or create damage. You know, a little pea-sized hail is probably not going to damage things. You know, light winds, you know, gusts of 25, 30 probably is not going to damage things. You know, so we don't issue of course, lightning doesn't make a thunderstorm severe because we'd have a warning for every storm. All right, so tornado versus funnel cloud. We're still talking about some definitions here. So in case you're wondering, tornado and funnel cloud, they look pretty similar, right? But the main difference is a funnel cloud has not touched the ground yet, whereas a tornado is technically extending all the way to the ground. Okay, so you know, just the key thing with this slide is if you see a funnel cloud, make sure, and it's not touching the ground, obviously, then make sure you report it as such. Okay, and if it's touching the ground, well, that's a tornado. So that's how you would report it if it's touching the ground. I'm going to take a quick sip of water here, so pause for 5 seconds. Okay, so thunderstorm ingredients. Do you remember back? I think I mentioned this before, but do you remember back in you know, grade school, middle school, when we were first learning about weather, and we got the what do you call it? The water cycle chart. Okay, this image has been around forever, And, and it's a cycle. It's a water cycle, right? So what's step one of the water cycle? Step one of the water cycle is water that's evaporating, okay? And so, you know, in order to create clouds and precipitation like you see here or here, you need water vapor, right? And water evaporation can happen off oceans, can happen off lakes, can happen from, you know, transpiration, water vapor coming from, you know, plants and vegetation. But you need water vapor in the atmosphere, okay? And that water vapor, once it's there, then it rises, okay? And what happens when it rises? It cools. And when water vapor cools, what happens? It condenses back to liquid, okay? And that's what creates the cloud droplets. The clouds are just made up of little water droplets. I mean, just literally droplets of water. That's what makes a cloud. And then what makes the rain? Well, it's bigger droplets of water. As the water droplets get bigger, well, then it goes from cloud droplets to rain droplets. Okay, but how did this happen? Well, this happened because there was water vapor in the air from evaporation, and then it rose up into the sky and it condensed. So as a meteorologist, one of the things that I am most concerned with, one of the things that I look for, well, there's two things I look for. Number one, is there adequate moisture? Okay, you need to have moisture to create clouds and rain. Okay, but number two, once I have the moisture in place, then I need something to make the air go up. So as a meteorologist, I am looking for what we call lifting mechanisms, things to cause the air to go up, right? We need air to go up. And as air goes up, that's what creates the clouds and precipitation, okay? So I, quite frankly, as a meteorologist, I'm concerned about all aspects of the water cycle, but this part right here is the part of the water cycle that I am really most interested as it relates to predicting weather and letting you know when it's going to rain or maybe when there's going to be thunderstorms. Okay, so anyway, keep that in mind, because the three ingredients we need for a thunderstorm is moisture. We talked about that already. A lifting mechanism, something to keep the air going up. And then finally, something to keep the air going up, right? Because a cold front can be a lifting mechanism, but that only contributes to air that rises only a couple hundred feet, maybe 1,000 feet, whereas instability keeps that upward movement going. But basically 2 and 3 are pretty much what I just showed, the rising, the lifting mechanism, if you will, or the air going up, okay? It's just the cold front gets it going, the instability keeps it going, okay? Now, I'm not just concerned about air going up in any shape or form. In order to create a thunderstorm, what you need is a really concentrated upward movement of air, very concentrated. And when it's very concentrated over a small area, we call that an updraft, okay? An updraft. When you have a very concentrated rising of air, all right? So updrafts, you know, weak updrafts usually result in, you know, ordinary showers, whereas strong updrafts can give you thunderstorms, sometimes even severe thunderstorms. All right, so updraft is very important, right? Well, there's a fourth ingredient, and that's called wind shear. Okay, so as the air is rising, remember how important the rising air is. As the air is going up, okay, it's creating all these raindrops. You see them here in this image here on the left, all these little water droplets, right? Well, if this updraft just remains vertical, after the raindrops are formed, what'll happen is eventually these raindrops become too heavy for the updraft to sustain it. And as these water droplets start falling down, that destroys the updraft, which created the water droplets. So the idea here is that, you know, you've got your updraft, it creates the rain, and then when the rain falls, it kills the updraft. Well, that happens when the wind is very light, or if it doesn't change. If the wind does not change with height, then what happens is the updraft remains vertical, okay, straight up and down. All right, so what we look for when predicting severe weather is for winds to increase with height, like you see here. Each arrow, the length of the arrow represents wind speed. So as winds increase with height, what that does is that tilts the updraft. So the updraft creates the rain, but the rain falls out away from the updraft that created it. So the updraft is able to persist. Okay, and this bottom sentence here is the key. The longer the updraft lives, the stronger the storm can become, and the better the chance for severe thunderstorm impacts. All right, so wind shear. All right, so there's 3 types of thunderstorms, and single cell, multi-cell, supercell, and they're all basically dependent upon, guess what? Wind shear. So a single cell thunderstorm basically is just as the name implies. You have this updraft, you have this towering cumulus, and then the rain forms, and then the rain, begins to fall out, and because the winds are light with height, the downdraft basically kills this updraft. Okay, and then eventually we call that the dissipation stage. All right, so a single cell thunderstorm only lasts about 20 minutes. It doesn't last long enough for it to become severe. That's because the winds are light, or the winds don't change as you go up in height. On multi-cell, on the other hand, typically at times may produce severe weather. That's because there's a little bit of an increase with wind speed with height. So the winds might be fairly light at the surface, but then they become a little bit stronger in the middle of the cloud, and then they're kind of stronger at the top of the cloud. And what you get is this tilt of the updraft, and you have your downdraft that falls out ahead of it, which then creates an outflow, if you will, of cold air from the rain-cooled air. And then that outflow creates a little mini cold front like you see right here. And I know my screen's getting kind of messy here, but it creates this, as this rain-cooled air spreads out, it creates like a little cold front. And then that initiates a secondary updraft, one that's kind of trailing it, if you will. And so this becomes a repetitive cycle, okay? And if the winds are oriented in a fashion that organizes this, you could end up with something like eventually a squall line of sorts. So multi-cell thunderstorms occasionally produce severe weather. Again, increasing winds with height. Now, the worst of the thunderstorms is the supercell, and that's because the winds are really, really highly sheared. In other words, you get a tremendous amount of increase of wind with height. Okay, and while that is the least common type of thunderstorm, it almost always produces severe weather. And if I may, here, let me clear the screen here so there's no highlights. But there's a lot of features in the supercell thunderstorm. And I know this is a very complex graphic here, but the key things, there's 2 key things, maybe 3 key things I want you to focus on. Number 1, the updraft you see here is tilted. But not only is it tilted, but the updraft is rotating as well. You see this little rotational type, looks like a coil, if you will. That is a rotating updraft. The other thing I want to call your attention to is so what that does is that builds the storm vertically. You have a deep, tall thunderstorm cloud, and essentially you've got heavy rain, maybe some hail that's forming in the forward flank, and all that rain begins eventually to fall out at some point, and we call that the forward flank downdraft. And as this rain spreads out, well, as I mentioned earlier, it creates like a little bit of a cold front. And as it's spreading out in a way, warm, humid air could rise up over top of it and create this little low-hanging shelf cloud. So we'll talk about that in just a minute. And the other thing I want to draw your attention to is this part right here called the wall cloud. Now what happens is with a supercell thunderstorm, air is flowing in so quickly. We call this the inflow jet, that there's just a tremendous amount of humid air flowing into this storm, and it's condensing really rapidly, particularly where this updraft is at its strongest. And because it's condensing so fast, it creates a lowering of the cloud base, which is also could be rotating. And if this process continues and can get stretched out, then eventually a funnel cloud may form. Okay, so that's a little quick look at tornado genesis, but I want to focus on two features of the thunderstorm. Number one, the shelf cloud, and number two, the wall cloud. So let me clear the screen again, and we'll go to our next slide. And the shelf cloud, again, it's warm, humid air where you see red arrows rising above the rain-cooled, dense air that's cutting underneath of it, the blue arrows. And what that does is it creates a low-hanging, dangerous-looking, somewhat kind of scary-looking cloud, if you will. And a lot of times people mistake that for funnel clouds or even tornadoes, okay? But remember, while these low-hanging clouds look very threatening, tornadoes do not form out of or from shelf clouds, okay? What they can tell you, however, is that strong straight-line wind gusts are approaching. Not maybe damaging, maybe not. It's going to be windy, okay, when that gust front or when that shelf cloud gets to you, and impending heavy downpours. And also another way to tell the difference is a shelf cloud extends across a large part of the sky. All right, so that's the shelf cloud. Now the other cloud, the other feature I wanted to point out is the wall cloud. Remember, right in the middle? All right, now the wall cloud, again, is a narrowing of the cloud base due to rapid inflow and that rapid moist air condensing. Now, since it's condensing and it's lowering, and it's also in conjunction with rotating updraft, how will you know whether it goes on and produces a funnel cloud or a tornado? Well, number one, the rotation has to be present. Well, and without it rotating, it's not going to go on and produce a tornado. Again, the rotation is key. Rapid vertical motion, strong moist air blowing into the storm. And then finally, it doesn't happen in a matter of seconds. It can take some time. So unfortunately, it is incredibly rare to see these four things in central North Carolina. And it is incredibly rare to see a wall cloud and to be able to look at it long enough to recognize these four things and get a sense of whether it's going to produce a tornado. Generally, the only part of the country that you can see this whole process is really out in the plains, where you could see it, see for long distances. Now, you might see a wall cloud here in central North Carolina, but to be able to see a wall cloud forming, persisting, strong winds blowing into it, and then going on to produce a funnel cloud, yeah, I mean, there's just too many trees, buildings, too much terrain to really be able to see all that happening here in central North Carolina. But if you do see a lowering of the cloud base and you're wondering if it's an actual wall cloud, just again, look for number one, look for rotation. See if it's rotating, okay? And if it's rotating, then give us a call and let us know. All right, so again, wall clouds developing into funnel clouds, this is what it may look like. If it does go on and produce a tornado, usually a tornado is mature when it's standing vertically. Okay, this is one way to know. Okay, the tornado cycle, it's vertical. Okay, it's just straight up and down in all these examples. Okay, and then finally, a dissipating tornado would look sort of like this, where it's kind of thinning out and getting kind of just kind of raggedy looking. Now, this could still be a threat. Look how we call this a rope tornado. Now, clearly this is still a danger because it's in contact with the ground. You can see that debris. See the debris getting kicked up here? Then that means it's still in contact with the ground and creating damage. Here we can't see because the trees are blocking it. But here, do you see any debris? No, there's a gap here between the rope and dust. So that lower right one is not in contact with the ground anymore. You can see the rain. This is all rain, by the way. So that's what it may or may not look like when it's dissipating. All right. There's a lot of stuff that can look like tornadoes and funnel clouds, but aren't. Okay, and we call these lookalikes. So here's a classic example of a tornado lookalike. These are all rain shafts, believe it or not. So what you got is you've got rain here, and there's no rain here and no rain here. You've got rain here, but no rain here and no rain here. So that means it looks like it just happens that the downburst. This is more of a downburst signature than anything else, but it happens to take on the shape of a funnel. Okay, so if you saw something like this, look and see if it's rotating. If it ain't rotating, then it's not a tornado. Same thing with this bottom image. Okay, so you're still not sure. Well, how do you know if it's a tornado or funnel cloud? Well, one key thing to differentiate a tornado versus a funnel cloud is the presence of debris. Clearly on the left side, that's a tornado because there's lots of debris near the surface. But on the right side, a lack of debris confirms that this funnel cloud has not yet reached the ground and become a tornado. Thus, you'd report that as a funnel cloud. And again, not all funnel clouds go on to produce tornadoes. Not all funnel clouds produce tornadoes. Okay, if you saw the thing in the lower right, but the storm was in the process of weakening overall, then chances are it's not going to produce a tornado. All right, some other clues, other visual clues of a strong storm. What's interesting about the feature there on the top, okay, and what's nice about doing these classes virtually is that I have the opportunity to draw on the screen. When I do it in person, I can't draw. So anyway, let me erase my drawings here. Now you might be wondering, well, why does the anvil spread out? Why does it look like a saucer or like a UFO? Okay. Well, the reason it looks like reason that the top of the thunderstorm cloud, these clouds spread out into a UFO shape or saucer shape, is because we are transitioning from the troposphere, where weather occurs, to the stratosphere. Okay. Now, in the troposphere, you can have rising air and humidity and instability, but once you get into the stratosphere, the temperature increases with height. So the temperature, as you go up, instead of cooling with height, it increases with height. And that creates a very, very stable environment. And stable environments do not promote rising air. Remember, updraft, rising air, that's what creates clouds and precipitation. A stable environment, when the temperature is increasing with height, like it does in the stratosphere, does not promote rising air. In fact, it prohibits it. So the saucer tells us, or the UFO or the anvil tells us, well, that's where the stratosphere is pretty much beginning. So if you can actually see clouds shooting above the what we call the tropopause, which would be right here, okay, if there's clouds shooting above the rest of the UFO or the saucer or whatever you want to call it, the anvil, that is one heck of an updraft. That not only did it create the storm, but it's puncturing through into the stratosphere. So an overshooting top suggests a powerful updraft and thus a powerful storm that probably has damaging winds and large hail. Okay? All right, the other thing at the bottom, look at these main storm tower. See how mushy this is? It's kind of like just mushy looking, jagged, and it doesn't really have well-defined sides. This has a very well-defined edge, a crisp look to it. That suggests a stronger updraft. versus a weak updraft suggested by the one on the right. And remember, the stronger the updraft, the stronger the storm. All right. All right, so let's wrap it all up and kind of, this is the last couple slides of the presentation, and we'll be through with the class here. So spotter safety again is our top priority. Okay, that should be the objective of every spotter. Never want to put yourself in harm's way. Okay, and that means doing, again, the classic example, running out into the hail to measure it. You'd be putting yourself in harm's way if you did that, right? So wait till the storm's over, for example. All right, when you do call, okay, to make your report, these are sort of the basic things that we are going to ask you. What's your name? Where are you at? What kind of weather are you seeing? When did it start? How long did it last? Can we get your phone number so we can call you back in case we have any follow-up questions? Those are some things we might ask you if you call to report severe weather. We no longer give out spotter ID numbers because they're not required. We just don't deal with the spotter IDs anymore. Okay, so 7 things to include in your report. All right, so severe weather reporting handout. Oh God. So again, we're looking at the spotter handout right here. Okay, and let me zoom in a little bit here. So again, if you haven't downloaded it, go ahead and download it now. And let's just go right down the handout. Okay, again, I hand these out in-person classes. So so again, spotter ID numbers, they're no longer issued. Now, if you don't mind, if you would like to be included in our database of official spotters, okay, the way to do that is to click on this link, and that will take you to another web page, okay, where it says click on this link to register for NWS Raleigh SKYWARN. Go ahead and click on that, continue, and then basically we just ask, okay, how did you take the class, your name, your location, just some basic contact information. And we do not share this contact information with anybody. We don't oh geez, gosh, where did that form go? Let me try to download it again here. There it goes. All right, so we don't share, when you click this link and fill out our registration, we don't share that information with anybody. What we do with that information, we take your name and address, and then we take your address and we geocode it for Latin lawn, and then we're able to overlay that over top of our radar data. When we're tracking severe weather at the National Weather Service, we can see where all of our registered spotters are located. Okay, and then this way, after the storm is over, or sometimes even the next day, if we see that a storm has gone over to your location, we might give you a phone call. Okay, so don't be surprised if after a storm is over, or maybe even the next day, you get a call from us if you haven't called us already. Okay, and that's what we do with your information. Again, when you click this link right here to register for our database. All right. So when should I call the National Weather Service? Okay, tornadoes. Okay, real basic stuff here. Wall clouds and funnel clouds. If you see funnel clouds or wall clouds, again, watch for rotation. If it ain't rotating, there's no reason to call. Okay, flash flooding. If you see roads that are closed, barricaded, DOT put up road closed signs because the water's flooding the road, please give us a call. Winter weather. At the end of the event, when you measure the snow, go ahead and give us a call. If you measure the ice at the end of the ice storm, go ahead and give us a call and let us know how much snow or ice you received. Any type of wind damage, trees down, structural damage, hail. At the end of the event, go out and take a look at the largest hailstone, and if you can, measure it and call us and let us know how big it is. If you don't have a ruler, compare it to a coin, penny, dime, nickels, a quarter, or golf ball. Hopefully you don't see anything bigger than that. You know, and let us know what the largest size hailstone. Tropical storms, hurricanes, basically at the end of the storm, how much rain you got? Was there any wind damage? Was there any flooding? Okay. Elsa says, do we need to call or can we text? So on this next page, if you flip the page over, Elsa, great timing of you asking that question, because the next page, flipping it over, shows methods to report severe weather. Okay, so the basic answer to your question, Elsa, is we're not really we're not particularly concerned with how you get it to us, just as long as you get it to us. Okay, so the phone call is usually the most efficient and quickest, but we do have a web page here that you can submit it. It's online. You know, a picture is worth 1,000 words. I can't emphasize that enough. Pictures are great. And if you can, email it to us at nws.raleigh@noaa.gov, or go ahead and tweet it or put it on our Facebook page. Many SKYWARN spotters are amateur radio operators as well. So if you happen to be among the amateur radio community, probably the quickest, best way to report severe weather is via the Central Carolina SKYWARN net. If you're in the Triangle region and if you're in the Triad region, that's Triad SKYWARN, so you can see all the SKYWARN frequencies that are used. Those are the ways, the best ways, in my opinion, to get those reports to us at the National Weather Service. If all else fails, there's the phone number, 919-326-1040. Okay, now I ask that you, if you call 326-1040, make sure that you're sticking to the criteria that we have listed here on the front page of this handout. And the reason is because we only have two lines. You know, if you dial 1040 and then somebody else dials 1040, we can accept 2 of those calls at one time. But then anything beyond that, if a third person's trying, then they get a busy signal. So that's why we ask that you stick to the criteria listed on the front page. All right. So again, a lot of common sense here, using the guidelines, you know, remain calm. Don't exaggerate facts. Please don't exaggerate the facts. Okay. Don't send in fake or false reports. That's illegal. Yeah, I mean, all the stuff here you could read. Don't assume that someone else already reported it. Don't report something you didn't see for yourself. Delayed reports are also important, even days after the event. There's when reporting hail size, there's some good things to compare your hail to. All right, if you want more information, you love this class, but you just need a little bit more, check out our SKYWARN page. Check out, feel free to download our spotter guide, and I hope this link still works. And if it does, you're going to love this book. Oh, it does. Okay, great. Go to this link and download this. You will love this book. This class that I just taught, all the material is pretty much contained in this book. Okay. And in fact, my slides and the way they're laid out and how it's presented is often, it basically it follows the course of this book. There's some free online training from Comet Med Ed. There's our Twitter and Facebook page. I want to give a plug to CocoRaws. What is CocoRaws? That's Community Collaborative Rain, Hail, and Snow. Okay. If you are really into measuring rain, snow, or hail, then this is basically, this is like SKYWARN just for rain, hail, and snow. Think of SKYWARN if it was nothing but rain, hail, and snow reporting. That's what CocoRaws is. And we dearly could use CocoRaws observers in Central North Carolina. If you're not set up with this, this is a great thing to go along with SKYWARN. Okay, so definitely check that out. Yeah, so give that a look when you get a chance. Oh gosh, I closed my browser. I didn't mean to do that. Let me redown. Okay. All right, what else do we got here? Spotter Network. I don't know if this is still live or not. Oh, it is. Okay. So if you like being a spotter, but you really need more, okay? Spotter Network is basically like, it's like SKYWARN on steroids, to use an analogy. Okay, so you know, the classes are much longer than this. They're more involved. There's tests. There's much more well-organized training. Okay, this is like really serious um, network of folks who like to spot weather. All right. So give that a look if you really like what you did tonight, but you want to just take it to the next level. All right. If you want to, if let's say you'd like, you're taking this class, you want some, you know, you want to turn it in for, you know, professional development credit or something like that, and you need a certificate, go ahead and click on this link right here. Okay, and it asks for a password. The password is just simply SKYWARN. Okay, just like I have right there. Hopefully you can see that. And when you open that file, that gives you a certificate form, and you could just fill it out. And you could say, okay, when did I take the class? March 10th, 2022. All right. So there you go. That's how you get a certificate for completing SKYWARN weather spotter training. Just fill out your name, fill out the date, hit print, and that's, I know it's a little bit cheesy. It's, you know, it's you're kind of doing it yourself. You know, you're not getting it in the mail from us. But again, we live on limited resources these days. So we're trying to, you know, for folks who want a a certificate, this is the best way we can do this for you. All right. All right. So quite frankly, I think this form pretty much has everything. Let's see. There was one other slide I think I wanted to show. Hang on here. Bear with me here for just a second. Oh, okay. Examples of things not to report. These, I'll just let you read these for yourself. Again, we only have 2 lines, and you know, when somebody calls our spotter line and says the sky is really dark to my west, which is an actual report I did take one time, or the lightning is severe. You know, I mean, I love to talk about weather, and I'll talk your ear off about weather, but these kind of reports don't meet the criteria on the handout, and it's you know, taken up phone time. So again, we just ask that you stick to the criteria. Again, oh, that's an old email address, so let me skip that. All right. Again, just some final thoughts. I've already shown all this. Let's go back to this page. Again, this is kind of like the one-stop, one-page, well, there's 2 sides to it. Your one-page summary of this class. So so anyway, definitely print a copy of this off for yourself, and put that on the refrigerator. All right. So that more or less wraps up our SKYWARN spotter training class.